Right, so we're going to look at quadratic patterns or quadratic sequences. So you'll already be familiar with linear sequences, and they're also called arithmetic ones, and now you're looking at quadratic. So you should know straight away anyway that in quadratic sequences, the second difference is common. So in linear ones, it's always going to be your first difference. Quadratic is going to be your second difference. So the way they could present this question to you could be in a line of sequences like that, so like just a list of numbers. They could have like triangles, so they could have 3 triangles, the first one, 12, the next one, so on. They could present it in any kind of shape or form, so just don't just assume because it's given to you as a list of numbers it's going to be linear. It could be quadratic as well. So the 4 questions I'm going to ask are going to complete in this video is writing the next 3 terms, describing the sequence, finding the values of B and C, and hence finding another value. So the first thing we have to do, I suppose, is when we're given a sequence, is figure out if it's linear or if it's quadratic. So if I write out the sequence, we have 3, 12, 29, and then 54. So the first thing that you're going to do is you're going to check the first common difference. So you're going to say from 3 to 12 is plus 9. From 29 to 12 is going to be 17. And the way you are doing this, just in case you can't remember, or just in case they ask you an algebra question, is you take one number and subtract the number in front of it, and that'll give you your common difference. Take the number, subtract the number in front of it, and give you a common difference. So 54 minus 29 then, so we know 54 minus 29 is 25 is our next common difference. From here to here is 25. Okay, so it's obviously not linear because our first common difference is not the same, because it's 3 different numbers there. So if we go from 9 to 17, we know that's plus 8, and 17 to 25, we know that's plus 8. Therefore, our second difference is common. It's 8. And so that's the way if we had to describe this sequence, we'd say it's quadratic because second difference is common. And that's what you write down, so because your second difference is common. So the first question that they asked was write the next 3 terms. So we'll have to continue this on. So we know if we have, so use your calculator for this because it's really easy to make a mistake. So you're going to have 25 there. You're going to add 8 to 25. So 25 plus 8 is going to give you 33. That means you have to add your 33 to the 54, which gives you 87. So that's just next term. Now you know, so go from your second common difference, you have to add 8 to 33. It'll give you 41. And add 41 to your 87, which will give you 128. It's your second term. And then for the last one, we know we have to add our second common difference, which is 8. So we have 41 plus 8, which is 49. And add 49 to 128. So 128 plus 49, 177. So you have your 3 next terms. So that's okay as well. So your next 3 terms then are 87, 128 and 177. So the next part, probably the part that catches people in quadratic equations or quadratic patterns, is finding the value of B and C. And it mightn't be B and C, it might be called P and Q, it could be called R and S, you just don't know. But I suppose what we have to realise is when we have a quadratic sequence, the formula that we use is Tn is equal to An squared plus Bn plus C. So we don't use, the one Tn is equal to A plus N minus 1 on D. That's only for linear. And this isn't linear, so you're not going to use that one. So the one for quadratic is actually not in your log tables, but you should be able to remember because it's like an x squared x in number, except you have A, B and C written into it. And your x is n, obviously. What you should all remember from when we did this was 2a was equal to your second common difference. So like when we see a, what they gave us un, they just changed u. They had 4n squared plus bn plus c and find b and c. So they told us that a was equal to 4. So a lot of the time they'll do this for you, but just in case they don't, you need to know that, well, 2 times a is equal to my second common difference, and my second common difference this time was 8. So a was equal to 8 divided by 2, so a was equal to 4. And they had it filled in, as I said, they had it filled in for us already. But just in case they don't, and you do have to calculate it yourself, don't forget that 2a is equal to your second common difference, and you can calculate a. So generally they'll have a calculated first, but we have to find b and c. So the way we go about doing so I'm just going to write it out again. So we have un is equal to 4n squared plus bn plus c. Find b and c. Okay, so un means the nth term. So what we're going to do is we're going to pick u1, which means the first term. And instead of writing n, I'm obviously going to write 1. 4 times 1 squared plus b times 1 plus c. So it's the first term. And we know if we look at the sequence, the first term of the sequence was 3. We knew that that was u1 or t1. We knew that 12 was u2 or t2. We knew that 29 was term 3 or u3. So if I'm after writing term 1, I've subbed in 1 for n, I can let that whole thing equals 3, because 3 was the first term of this sequence. So I'll have 1 squared is 1 by 4. Make sure you follow BOMDAS. That will just give you 4. It will not give you 16. Plus b plus c is equal to 3. So I'll have b plus c is equal to 3 minus 4. B plus c equals minus 1. I have one equation got. You know there's 2 unknowns. You know you're going to end up with 2 equations, 2 unknowns. You know you're going to be doing a simultaneous equation. Let's try to find the second one. So instead of writing term 1, I'm now going to write term 2. And everywhere I had an n, I'm going to sub in a 2. So b times 2 plus c. And I know I can let that all equal to 12, because term 2 is equal to 12. So I'll have 2 squared is 4 by 4 is 16 plus 2b plus c is equal to 12. 2b plus c is equal to 12 minus 16. 2b plus c is equal to minus 4. As I said, I have 2 equations, 2 unknowns, so you know that I'm going to have to do a simultaneous equation to find the value of b and c. So b plus c equals minus 1, and 2b plus c equals minus 4. Get all the numbers to be the same. So I'll cancel my c's. Minus b plus 2b gives us b equals plus 1 minus 4 is minus 3. Then I'll sub it back into one of my equations, minus 1, so I'll have minus 3 plus c equals minus 1. C is equal to minus 1 plus 3. C is equal to plus 2. So now I have my equation, and my values for a and b. And if they wanted me to write back into their equation, which was 4n squared minus 3n, b was minus 3 plus 2. And that would be my equation. So that in again. So just to look at the last question they asked us, hence find u20. So I'm just after rewriting my whole formula. So I filled in what we found out. So un, I'm just going to write that again because it's messy, 4n squared minus 3n plus 2. And now they want us to find u20. So what we're going to do is sub in 20 everywhere that we had n. So we'll have 4 times 20 by 20, so 20 squared is 400 minus 60 plus 2. So we'd have 1600 minus 60 plus 2. So it'd be 1542. So u20, so the 20th term of that sequence would be 1542. And that's all there is to quadratic sequences. As I said at the beginning, don't always expect it to be in number form. Like oftentimes in quadratic sequences, it's an image. It's like triangles or squares or dots, all increasing. Okay, that's it.